If you watched the first video in this series, Logical Electrical Switches, number 1, Introduction, you might still be asking this question. When someone assigned names to electrical switches, did they base the name on 1, how many terminals are utilized in each respective switch, or 2, how many circuits or parts of a circuit the switch controls? In that first video, I tried to show that the use of only one of the two above options to name switches will not yield the common contemporary names for those switches. To get the names that you are currently familiar with, the naming process must have been a combination of the above options plus the random consideration of outside criteria. Considering the two above options, let's take another look at the 3 common electrical switches that were discussed and renamed in my previous video. Let's try to figure out exactly why, from the onset, those switches were given confusing, imprecise names. Note, in this video, to keep it simple, we will exclude from discussion the ground terminal. Additionally, we will not get hung up on the alternating current aspect of current flow. We will simply focus on the terminals, common and traveler, and on the switching capabilities of each respective switch. Now here's the name that I've given to the so-called single pole switch. That's what it's called in mainstream. That's a conventional name, single pole switch. I have renamed it single station switch because it's logical, okay? So here's the front view with the on position, front view with the off position, and here's the side view. This is the so-called single pole switch. In the electrical field, pole can mean either 1, a point of connection, 2, a live hot connection, or 3, the number of separate circuits that a switch or circuit breaker can control. Was this switch named as such based on the points of connection, that is, its terminals? I don't think so. It is referred to as single pole, and yet it has 2 terminals. The 3-way switch has 3 terminals, and the 4-way switch has 4 terminals, and they are apparently named with at least some consideration for their respective number of terminals. Why is this switch not called a 2-way switch? Again, it is called a single pole switch. But is there any flavor of the number 2 in this switch? Maybe. It has 2 terminals. Remember, we're not counting the ground terminal. Either terminal can be chosen for the line always live side. In other words, either one of these terminals can be used for the line side and the other one for the load side. It does have 2 switch positions, on and off. It does have 2 terminal live dead states. It's either live or live dead. In other words, live dead if the switch is off, and live if the switch is on. We see that there is an element of 2-ness in this switch, but it's still referred to as a single pole switch. Perhaps the name is based on the number of circuits or parts of a circuit that it controls. The single pole switch does indeed have only one circuit, the single pole switch does indeed control only one circuit or part of a circuit. Providing that there are no relays involved in this switching, this switch will control only one circuit or part of a circuit. So we see that the criterion of number of circuits controlled might have influenced the naming of this switch. However, logically, we have now another problem. The so-called 3-way switch and the so-called 4-way switch each, respectively, control only one circuit or part of a circuit, and neither of those 2 switches are referred to as single pole. That's right, neither. As such, we would be inclined to believe that the criterion of number of circuits controlled probably is not the main criterion for naming this switch. So how did it come to acquire and tenaciously hold on to this name for so long? I don't know. Maybe just laziness on the part of most people in the industry, or maybe the if it ain't broke, don't fix it mentality has prevailed. Who knows? All I know is that the name single pole stinks, so I changed it. The name I have given it is single station switch. Single station. It's one switch at one location. It's independent. It can stand alone. It works just fine all by itself. There are switch position configurations. One is on and one is off. You see one switch, one location, one on, one off. I call it single station switch. All right. Now the next switch I refer to as the double station switch. Mainstream, conventional, they call it three-way. That's what you'd call it, a three-way switch. Here's the front view, here's the side view, and here's the back view. As noted above, we know that the three-way switch controls only one circuit, so the number of circuits controlled criterion was obviously not a consideration when this switch was formally named. Even so, this switch would likely never be referred to as a single pole or single circuit switch. Maybe this switch was named as such based on the points of connection criterion, that is, its terminals. So we take a look and we find it has 3 terminals. Remember, we're not counting the ground terminal. One terminal is called the common, that's this one. The other 2 are called travelers. Here's traveler 1, traveler 2. There is the possibility that this switch is named as such because of its number of terminals. Again, however, we recall how the so-called single pole switch is not called a two-way switch. So why is this one called a three-way switch? What exactly are those 3 ways? It takes 2 three-way switches to work correctly in a 3-way setup. In one of those switches, the common will be live at all times, okay? And the other switch, on the other switch, the common will be live or dead depending on the switch position configuration. Still though, where is the 3 element in all of this? Let's look at a diagram for the 4 switch configurations possible with 2 three-way switches. Maybe we'll find that 3 element somewhere in the maze. In other words, the 3 concept. So here's an old diagram from my old notes. I just took a picture of the piece of paper, so if you don't mind, we'll look at this old piece of paper. So here you have 4 switch configurations for my double station switch. You'd call it a three-way, right? So in this case, you have your line side, right? Here's your line side three-way, and over here is your load side three-way. And you see that the live current comes in here to your common terminal, goes to your traveler terminal, through your traveler conductor, which is ordinarily red, not always. And then it meets over here at your traveler terminal, and it goes out the load side common, and it goes out to your load, and your light goes on, your fan goes on, or whatever. So this is the on position. And here you can study this on your own, but you see you have the off condition here, and you see why. See, current comes in, but it stops. And here you have another off condition. The current comes in, goes this way, but there's no connection here. So the load is not energized. And here's another one with the switch in the down position. Current will go on your white traveler conductor and pass on to your load. You can study this on your own. And you'll also see that I refer to these things called live dead states. On your line side, you have only 2 possible states, live, live, dead, or live, dead, live. And you can see that over here, live, live, dead, and then live, dead, live. On your load side switch, okay, you can have 4 possible live dead states. All right, and they're mentioned here. You see them here, and you see them over here on the actual switch. It's the same thing. So that's what you're dealing with my double station switch, or what you would call 3-way. All right. Now, granted, each switch does indeed have 3 terminals with their attendant 3 live dead states for any given moment. But that does not definitively tell us exactly what the 3 ways are, especially considering that the line side switch has only 2 possible live dead states and the load side switch has 4 possible live dead states. All in all, the name 3-way stinks. I have renamed it double station switch. It's 2 switches, 2 locations. When you see this setup, you know if you see one double station, or you'd call it a 3-way switch, that there has to be another one. It's a switch set. They come in a pair. They have to come in a pair or they won't work. And then there's switch position configurations. 2 are on, 2 are off. 2 switches, double. 2 locations, double. 2 on, a double, and 2 off, double. That's the name I have assigned to this switch. Okay, here's another switch. This is what you'd call a 4-way. That's the mainstream name for it. My logical name is triple station switch. Now this is a little weird, but let's talk about it. As noted above, we know that the 4-way switch controls only one circuit, so the number of circuits controlled criterion was obviously not a consideration when this switch was formally named. Again, just like the 3-way switch, this switch would likely never be referred to as a single pole or single circuit switch. The 4-way switch does have 4 terminals, okay? Remember, we're not counting the ground terminal. All 4 of the terminals are travelers. That is, there is no common terminal on this switch. So there is the possibility that this switch is named as such because of its number of terminals. Yet again, however, we recall how the so-called single pole switch is not called a 2-way switch. So why is this switch called a 4-way switch? Let's look at a diagram for the 8 switch position configurations possible with a 4-way switch set. A set composed of 2 3-way switches plus 1 4-way switch, okay? And again, here's some old notes. I took a picture of it, so we'll just look at the picture, the photo. Saves me a lot of time. Now, here's my triple station switch. You'd call it 4-way. And in these configurations, the line side switch is up. All right, in each case, the switch is up. And you can see the current flow here. And in this box here, that's your so-called 4-way. That's my triple station switch. Okay, you see what's going on in here. And you can see, just like in the other diagram, the live dead states. This common terminal's live, traveler terminal live, and inside your 4-way, here you have your live terminal, live going out, live on your load side 3-way, and live on your load side common, and it passes on to your load, and your light goes on, your fan goes on, but whatever, you have an on state, an on condition here. Here you have off. You can see clearly that your live side's here, but it's not connected. There's no connection, so your load is not energized. And here's another way to switch it. Here you have your live side. It comes in. All right. Now your 4-way switch is switched. So this current goes this way, goes on to this traveler here, this traveler conductor, and nothing happens because you see the connection is broken. Anyway, you can study this on your own. And you see here that on the line side three-way switch, there's only one possible line side up state, and that's live, live, dead. See, live, live, dead, all right? On your triple station switch, which you would call a four-way, that's what you call it, you have two possible states. There's only two here. It's live, dead, or live, dead, live. And then finally on your load side three-way switch, your live, dead states, there are four possible states. Okay, and you see that on here. You see this one, this one, this one, and this one. All right? Now, we have this switch in the down position. All right? And you have your line side three-way, you have your four-way switch, and your load side three-way here. And you see in this example, this is live on your line side three-way common. It passes on, passes through the four-way, and makes its way to the load. And you can study this on your own. You can pause it. And you can see here, down here, when you switch this, you can see what happens. And you switch it here. You switch this to the up position. All right, then your load's energized. It's kind of interesting and kind of a fun thing to study. But you see mainly here is you have all these different possibilities on the different respective switches. All right, your live dead states are different for each switch. In other words, there's only one possibility here, two here, and four here. All right, so keep that in mind when we consider naming. All right, we see from the above two diagrams that the given switch set affects four on states and four off states. Terminal-wise, it provides for the following terminal live dead states, which we just talked about. And you see what they are listed neatly. You can study this on your own. So you see for the four-way switch, the element or the essence of the number 4 does come into play. We're going to concede that. We're going to say, okay, well, you know, they got us there. Now over here, though, on the load side, three-way switch, with the line side switch up, right, you can have 4 live dead states. And with this line side switch down, over here on the load side three-way, you also have 4. But the problem is the 4 live dead states affected on the load side, all right, here, with the line side double station switch or three-way in the down position are duplicates of those affected with the line side three-way in the up position. So these here, these are just duplicates of these, so they kind of don't count. I mean, they are there, they exist, but they don't really matter. Now, as such, I have named this switch the triple station switch, and it's dependent. It's part of a switch set. You can't use it by itself. It's not going to do much. Oh, sure, you can goof around with it and make something work, but it's stupid. It's a switch, part of a switch set. It has to work with something else. Triple station, 3 switches, 3 locations. Triple, it's very simple. Switch position configurations, 4 are on and 4 are off. So we conceded that some people might say, oh, it's a 4-way because 4 on, 4 off. But no, what we do is we look at this and we say, well, what's the main factor here in naming a switch? Well, it's part of a set, all right? There's 3 of them. And the 3 switches are clearly visible. The 3 locations are clearly visible. The switch position configurations which exist are there, but they can only be imagined. You can't see inside the device box unless you take the cover off and pull the switch out. So I say the visibility factor, the 3-ness, overrides the 4-ness. That's just the way I think, but that's what I named it. Okay, now here's your what you would call single pole switch. It's actually a single station switch now. Here's what you would call three-way, and I call it the double station switch. And then here's what you would call the four-way, and I call it the triple station switch. An easy way to determine how many on-off configurations can be affected in any given switch or switch set, all right, is to simply look at the back of the switch. So here's kind of like the back or the side. Here's the back and here's the back, right? For example, take a double station three-way switch. The common to traveler 1 connection, or lack thereof, gives you one on-off state, and the common to traveler 2 connection, or lack thereof, gives you one on-off state. As such, you get two on-off configurations in total. And we know from our study, like what I just talked about, that this is correct. So if you look at the single station switch, you see that you have, let's say this is your line side, this is your load, you have only one on-off state. That's all you get, right? Over here, as I said, you have one on-off state here, and you have one on-off state here. And I couldn't find anybody on the internet who talks about this in such a fashion. This is very simple, and anybody can do this if you just look at your switch. Just look at the back. Now here's your so-called four-way. I call it the triple station switch. So how many configurations do we know? Well, we know that there's 4. And how do you get them? Well, you look at the switch. Common terminal 1, traveler 1. There's 1. Common terminal 1, traveler 2. There's 2 on-off states. Common traveler 2, excuse me, common terminal 2 with traveler 1 is your third. This is hard to say. Traveler terminal to traveler terminal 2 here is your fourth. In other words, I spoke incorrectly. Here's traveler to traveler, traveler to traveler, traveler to traveler, and traveler to traveler. And that sounds goofy, but that's how you get your 4 on and 4 off states. Okay, that was a little hard to say. So ultimately then, I stand by my decades-old names, and maybe somebody will submit these to the National Electrical Code. Maybe somebody will say, you know what, that's a damn good idea. I'm going to start talking like this. Who knows? I have no credentials. I have no college degrees, so no one's going to listen to me. But maybe somebody out there, a professional with certificates, maybe someone will listen to him and he can gain some ground with this. So single station switch, independent, works all by itself just fine. One switch, one location. You can call it single pole, but that tells you virtually nothing meaningful. Double station switch, it's dependent. There has to be 2 of them. 2 switches, 2 locations. The word double, you would call it three-way, which I really hate. Triple station switch, there has to be 3. There can be more, but there has to be 3. And 3 or more locations. Triple, you call it a 4-way, and I just talked about it. There is the element of the number 4 in there, but it's not enough. You can see the 3 switches, you see the 3 locations, and you know you have triple station. There are 3 stations that make this switch set work. That's very important for the mind. So your formal logical designations are here. And then I mentioned in my last video, the alphanumeric designations could be used as product or item codes on the product itself when it's manufactured. For example, single station switch, line load, double station switch, line 2 travelers, triple station switch, 2 travelers, 2 travelers. So the thing is, I didn't speak well in this video. I stumbled around a little bit, but the point is, I really, really do think these are good names, and if you study it and think it through, I think you'll agree. So that's it. Thanks for being incredibly patient, and have a great day.